Get this, over the last 50 years, natural disasters have gone from being relatively rare to a major global threat. The stats are mind-blowing today. It's estimated that a disaster is striking our planet every second. Since 1970, these disasters have taken more than 2 million lives in total. But what's really wild? Many of these tragedies aren't caused by massive earthquakes or hurricanes. They're often the result of super long droughts that leave people without water, or storms that seem to come out of nowhere, catching communities off guard. Even floods and extreme temperature swings have become deadly forces we need to take seriously, claiming nearly 115,000 lives over the years. Here's something that'll make you sit up and think. Our planet is facing a perfect storm of potential game changers. I'm talking about the Gulf Stream grinding to a near halt, or even the Earth's core slowing down dramatically. Both scenarios sound straight out of sci-fi, but what's even more striking? These seemingly unrelated events might actually be connected dots in a much bigger picture. Get this, our planet has been through not one, not two, but 5 massive extinction events throughout its history, wiping out trillions of species. And now, we're on the cusp of potentially becoming the 6th mass extinction event, all thanks to human activities. It's a sobering reality that's got scientists and experts sounding the alarm, warning us that our actions could have far-reaching consequences for life as we know it. You're right, let's dive into this further. Those mind-blowing mass extinctions we just talked about didn't actually spell the end of life on Earth. They were more like resets, the ones that wiped out around 96% of all species. That's still a staggering number, but not total annihilation. So, what does it mean for us humans and our population today? It brings up a super important question. At what point would human numbers drop to the point where we'd no longer be considered a dominant force on this planet? To find out, buckle up and join me as we travel back in time to explore the history of mass extinctions. It's about to get real. Fasten your seatbelts. We're about to take a journey back in time to 74,000 years ago. That's when Toba, a colossal supervolcano located in what's now Indonesia, unleashed its fury upon our planet. The aftermath was nothing short of catastrophic. A harsh volcanic winter set the stage for an impending ice age, and the devastating effects rippled through entire ecosystems. But here's where it gets really intense. This disaster didn't just impact animals and plants, it had humans in its crosshairs too. In fact, our Homo sapiens population may have shrunk to a jaw-dropping low of just 3,000 individuals. What does that mean? It means we went through something called a population bottleneck, a super sharp decline in numbers that's essentially a make or break moment for any species. Will they recover or disappear forever? The outcome was far from certain, and now it's time to explore what happened next. You're still here, watching this video. That's a pretty strong hint that humanity managed to dodge that ancient bullet. So, if we can squeak by with just 3,000 survivors after the next big hit, then it looks like our species has got some staying power. But what exactly is waiting in the wings to test us? Well, you might be thinking of a massive asteroid impact, just like the one that wiped out those iconic dinosaurs 6 million years ago during the Cretaceous-Paleogene extinction event. That's when a space rock as big as a mountain slammed into our planet, causing a catastrophic chain reaction and wiping out around 3/4 of all plant and animal species on Earth. It was a total annihilation. Now imagine a space rock so enormous, it's almost as wide as Mount Everest is tall. That's how massive the Chicxulub meteor was. And to make things even more terrifying, this cosmic behemoth was hurtling through space at an insane 20 kilometers per second before it made landfall. When it finally collided with our planet, the energy released was a staggering 72 teratons of power, equivalent to about 5 billion Hiroshima bombs going off all at once. Talk about an explosion of epic proportions. But the disaster didn't end with the initial impact. Things took a darker turn when the massive cloud of dust and debris shot up into the atmosphere, essentially blocking out the sunlight that our planet desperately needed. The devastating effects of the asteroid impact didn't stop there. It set off a chain reaction that would change Earth's ecosystem forever. With photosynthesis grinding to a halt, plants and algae began to perish, leaving behind a barren landscape devoid of food for countless animals. As a result, Most of the planet's massive creatures, weighing over 25 kilograms, including our prehistoric friends like non-avian dinosaurs, ammonites, plesiosaurus, mosasaurus, and many types of mammals, met their demise. But there was some good news amidst this mass extinction. Small mammals that made a living off insects or scavenged for carrion somehow managed to hang in there. So, the question remains, what about us humans? Let's take a wild ride and imagine a scenario where Chicxulub's twin is on its way. A massive, fireball-like stone hurtling towards us, bigger than Mount Everest. Picture this: you're sitting at your office desk when suddenly, through your window, appears the apocalyptic sight of an asteroid engulfed in flames, heading straight for you. What would you do? How could you possibly escape this cosmic catastrophe? The harsh reality is that the extreme heat from this asteroid would vaporize everything within a 1,000-kilometer radius even before it hits the ground, reducing all living organisms to nothing but ash. Imagine if Chicxulub's twin were headed straight for Manhattan. It'd wipe out nearly 105 million people before even touching down. Or picture London getting hit instead, resulting in a staggering loss of around 193 million lives in an instant. But what if this asteroid struck exactly where the original one did, about 66 million years ago? The heat blast would be so intense that it would claim approximately 3.7 million lives within just seconds. As for the aftermath, massive wildfires would erupt and spread across forests thousands of kilometers away, eventually engulfing entire continents, both North and South America, and the impact crater at ground zero. It'd be a whopping 300 kilometers in diameter, reshaping the very landscape. At impact time, this new Chicxulub asteroid would unleash so much energy that it'd vaporize roughly 70,000 cubic meters of rock. That's equivalent to 17 times the volume of the Grand Canyon. Just 8 minutes later, that vaporized rock would start cooling down and transforming into scorching ash. And if that weren't enough, the collision would also cause a massive earthquake with a mind-boggling magnitude of 10.1 on the Richter scale. Its devastating tremors could be felt as far away as Colombia and Kansas. But that's not all. The impact would also generate a massive shockwave in the form of a blistering wind gust, hurtling at thousands of kilometers per hour. This colossal force would flip cars and reduce buildings to rubble within an astonishing 2,200-kilometer radius. Combine that with the earthquake, and we're looking at a staggering loss of nearly 350 million lives. And if you thought earthquakes were the worst of it, think again. This impact would also unleash a monstrous tsunami, reaching a heart-stopping height of 1,500 meters, capable of causing unimaginable destruction along its path. Fasten your seatbelts, because this scenario's just getting wilder. The tsunami would crash down on the coasts of Europe, North Africa, Greenland, and even travel as far as New Zealand and Australia, leaving nothing but devastation in its wake. To put that into perspective, it'd be an astonishing 30,000 times more powerful than the Indian Ocean tsunami back in 2004, which tragically took over 230,000 lives. If this Chicxulub scenario played out today, we're looking at a staggering loss of 340 million people. But here's where things get truly eerie. The impact would kick up an unprecedented amount of ash, blocking out sunlight and plunging our planet into darkness for a mind-boggling 3 years. Now, you might be wondering, can darkness really be deadly? But here's where things take a turn for the worse. The prolonged darkness would be catastrophic for our planet's food chain. Most plants would struggle to survive without sunlight, and domesticated animals would also be severely impacted. With no food sources available, the consequences would be devastating. Up to 70% of all living creatures on Earth, including humans, could lose their lives. The relentless night would bring a drastic drop in temperature, adding to the death toll. Amidst this global chaos, medicine's ability to combat diseases would be severely compromised, putting those with chronic illnesses at extreme risk, and in the US alone, that's a staggering over half of the population, according to statistics from the CDC. So, just how massive would the effects of this cosmic impact be? The numbers are shocking. A staggering 90% reduction in Earth's human population is now being predicted. While that paints a bleak picture, there's a silver lining. Our species will indeed survive this mass extinction event. The bad news is that such a scenario isn't just fictional, it's an entirely plausible reality. To put things into perspective, The asteroid Apophis will make a close flyby of Earth in 2029, giving us a chilling glimpse of what could be. Thankfully, scientists have been monitoring this potentially hazardous asteroid, and so far, our planet is safe from collision. Now, let's talk about just how destructive one of these massive meteors could be. Its impact would release an unfathomable force of around 500 megatons, equivalent to a nuclear explosion that's 10 times more powerful than the largest ever tested. To put that into perspective, it'd be like witnessing a cataclysmic event on a scale unlike anything we've seen. But asteroids aren't our only spaceborne threat. If we travel back in time about 445 million years, Earth was vastly different below. A sprawling desert covered by the supercontinent Gondwana. Let's dive into Earth's past when life was just beginning to spread across its surface, during a time known as the Ordovician period. This era was nothing short of revolutionary, with an explosion in marine biodiversity called the Great Ordovician Biodiversification Event. Life underwater flourished at an incredible rate, and it's tantalizing to imagine how different our world might be today if this trend had continued uninterrupted. Perhaps life would have remained confined beneath the waves forever. However, a devastating mass extinction struck during the transition from the Ordovician to the Silurian period, wiping out a staggering 85% of marine species in an event shrouded in mystery. Scientists are still trying to pinpoint what triggered this cataclysmic event, which saw nearly half of all animal families vanish from existence, leaving behind a drastically altered world. The Great Ordovician Silurian extinction event left behind an ecological footprint so massive that it's still hard to wrap our heads around. Nearly 9 out of 10 marine species vanished, along with half of all animal families. Now, you might be wondering what could have triggered such a cataclysm. Scientists have been digging deep for answers, and one mind-blowing theory suggests it was none other than an explosion from outer space, a supernova. But how could a distant star's death throes possibly impact life on our planet? Sounds far-fetched, right? Well, hold on to your seats. Research by Adrienne Melott from the University of Kansas in 2016 actually found evidence that these cosmic events can have a direct, devastating effect on Earth's organisms. Let's dive into the research by Adrienne Melott, who went on an epic journey to uncover clues about our planet's past. She analyzed ocean floor samples from all over the world and made a groundbreaking discovery. Every single sample contained iron-60, a radioactive iron isotope with an incredibly long half-life of 2.6 million years. But here's the jaw-dropping part. Given Earth's age, this iron should have vanished eons ago. So, where did it come from? The answer lies in the extreme power of supernovas. These cosmic explosions are the only natural phenomenon that can create iron-60. Fast forward 2.5 million years ago, scientists like Melott think that a supernova lit up the sky, exploding between 150 and 300 light years from our home planet. That's why we still have those lingering remnants of radioactive iron on Earth today. But let's imagine what would happen if a star went supernova even closer, just 30 light years away. The view would be breathtaking, with a bright blue light dominating the sky for an entire month, shining day and night. This could seriously mess with our sleep patterns by disrupting melatonin production, but that wouldn't be the biggest issue at all. But that's not all. If a supernova happened just 30 light years away, Earth would also take a massive radiation hit. Gamma rays would flood our atmosphere, ripping electrons off atoms and creating an electrical charge imbalance. This would trigger a global lightning storm, setting off enormous forest fires across the globe. The worst-hit regions would be North America, parts of South America, Europe, North Africa, and Asia. These areas would face the full force of this cosmic catastrophe. And it's not just the initial destruction from the flames that we'd have to worry about. The long-term effects of those devastating fires would change our planet forever. The real doomsday scenario unfolds when these fires start pumping massive amounts of carbon dioxide into our atmosphere. We're talking about levels on par with what happened during the devastating Amazon rainforest blazes in 2016, which released a staggering 30 million tons of CO2, equivalent to Denmark's annual emissions. Just imagine the catastrophic consequences if all our forests were engulfed in flames. It'd be like unleashing a greenhouse gas monster that could turn Earth into the ultimate horror show, much like Venus, often referred to as Hell on Earth. But before we're trapped in this carbon dioxide nightmare, humanity would need to fight for survival in an unforgiving environment. But here's the worst part. A gamma ray burst isn't just about explosive lightning strikes or spectacular visual effects. It also unleashes a deadly torrent of unstable particles that can rip through human bodies like high-speed CT scans, causing irreparable damage to our cells and tissues. And if that weren't enough, the X-ray radiation that follows would be a 1-2 punch. Not only could it completely dismantle Earth's ozone layer, leaving us vulnerable to UV radiation, but this prolonged exposure would also lead to DNA mutations and cancer on an unprecedented scale, potentially wiping out millions of lives. Imagine a world where human existence is put to the ultimate test, like the marine life of the Ordovician period that got wiped out long ago. Now, you might think we'd be completely goners if a supernova hits us head-on, but scientists are divided on just how close it needs to get. Some say 30 light years. Others claim it's still safe at 300. Talk about differing opinions. But here's the kicker: the closest star that could become a supernova and give us a serious scare is Ik Pegasi b, chilling at a mere 154 light-years away. And get this, we're looking at a possible doomsday date around 2 billion years from now, which isn't even a blip on the cosmic calendar clock. Hold up, space fans. It looks like we've got a more pressing threat right here on our home turf. Did you know that way back around 200 million years ago, Earth itself nearly wiped out life as we knew it during the Triassic-Jurassic extinction event? This was no asteroid impact or distant supernova. Our planet's own air became toxic thanks to massive volcanic eruptions. These natural disasters altered Earth's atmosphere, and the resulting changes made our home a hostile place for most animal species back then. About 75% of them met their maker during this period. The stage was set in the heart of Pangaea, where the Central Atlantic Magnetic Province was brewing up a perfect storm that would change life on Earth forever. Imagine a volcanic firestorm so massive that it engulfed an area roughly the size of modern-day Russia and India combined. Talk about epic. This wasn't just any regular volcanic activity. Scientists think that up to 6 million cubic kilometers of molten rock poured out, spewing toxic gases like carbon dioxide, sulfur dioxide, and even mercury into our atmosphere. CO2 levels skyrocketed from 1,000 parts per million to an astronomical 4,000. To put things into perspective, we hit a record high of just 421 parts per million in 2022. With the climate taking a drastic turn, global temperatures soared by as much as 10 degrees Celsius in some areas. This was no slow burn, it was a rapid increase that would have been catastrophic for life on Earth, setting the stage for one of the biggest mass extinctions in history, the Triassic-Jurassic extinction event. The first dominoes fell, and it all started with our green friends, plants. The extreme conditions brought on by the volcanic eruption wiped out a staggering 17 to 73% of plant life. That's like losing most of your favorite parks and forests at once. With fewer plants around to munch on, herbivores began to starve, followed closely by their predators. But just as we thought things couldn't get worse, another disaster was brewing beneath the waves. Underwater volcanoes were also spewing toxic fumes, making ocean water so acidic it practically corroded away coral reefs, a crucial habitat for countless marine species. It's like our planet had turned into one giant, fiery, and deadly storm. But here's the thing. What might seem like a catastrophic extinction event for ancient creatures could be an absolute nightmare for us today. With over 800 million humans relying on the oceans for their survival, losing most aquatic life would mean starvation for countless families and communities. And it gets even worse, the scorching heat that wiped out those ancient plants and animals. It'd be a death sentence for at least 20 million people in equatorial regions, where temperatures would skyrocket to lethal levels. Let's dive deeper into the devastating effects. You might know that hunger already claims a life every 4 seconds. That's around 9 million people dying from starvation each year. Now, picture this nightmare intensifying. A whopping 3/4 of global harvests could be lost due to carbon dioxide emissions, pushing those heart-wrenching numbers through the roof. And if we thought that was enough, imagine toxic gas and mercury vapors spreading across entire regions. We're talking about areas like central Brazil, parts of North and Central America, multiple European countries, and West African nations, all part of the former Central Atlantic Magnetic Province. But here's the silver lining: a global volcanic disaster isn't something we need to worry about right now. But hold on to that thought for a second. We're not off the hook yet. A geophysicist named Daniel Rotman is sounding the alarm. By the year 2100, our oceans could absorb an astonishing 300 gigatons of carbon dioxide, pushing us towards a catastrophic tipping point. And here's the chilling part. His research suggests this could trigger a brand new mass extinction event that'll take about 10,000 years to unfold. But there's something even more pressing in the cards, and it all started back in 2006. Let's look back at one of Earth's most brutal episodes, the Permian-Triassic extinction, which happened around 250 million years ago. This devastating event wiped out a staggering 96% of all animal species. From ocean dwellers to vertebrates, even insects didn't escape unscathed. Fast forward to that brutal Permian-Triassic era, when the largest insects Earth has ever seen vanished forever, alongside trilobites and those intimidating sea scorpions. So, what could have brought down such an incredibly diverse range of life forms? Experts have been piecing together several theories, but one of them is particularly spine-tingling: the Clathrit gun hypothesis. Here's why: deep beneath our oceans and seas, there might be a substance called methane hydrate, essentially a frozen water ice mixture containing massive amounts of methane. Now, just like oxygen, this gas can dissolve in water, but to keep it in its solid or liquid state, it needs the perfect balance of pressure and temperature conditions, which, as you might have guessed, can be easily disrupted. Let's dive deeper into the numbers behind this hypothesis. Chemical engineer Gregory Riskin estimated that at the end of the Permian period, our oceans could have held around a staggering 10,000 gigatons of methane. Now, for a full-blown catastrophe to unfold, all it would take is one nudge, but during the initial stages of the Permian extinction, we saw a series of pushes that made this disaster possible. What's key here is that just as these events were unfolding, something massive happened. The so-called Siberian traps became active. These are vast magmatic rock formations spanning 7 million square kilometers. When these enormous systems spewed out huge volumes of lava from their cracks, it not only raised ocean temperatures, but also melted methane hydrates at the bottom or released dissolved gas into the water. This deadly combination could have triggered a massive release of methane, amplifying the catastrophe and leading to the extinction event we're discussing. As the methane flooded into our atmosphere and oceans, it would have altered water pressure levels, unleashing even more of this potent gas. At this point, the disaster would have reached a tipping point. There'd be no turning back. Riskin's research suggests that when methane mixes with air, it creates an explosive cocktail just waiting to ignite. Imagine deadly clouds of this mixture being swept deep into continents by powerful winds. It only takes a single lightning strike to set off this aerial bomb, unleashing devastating explosions. But the damage didn't stop there. These blasts could have also sparked massive forest fires that would have further ravaged the planet. Now, it's worth noting that not everyone agrees on this scenario, and we'll be exploring an alternative theory proposed by paleontologist Gregory Redelak in our next segment. But not everyone buys into that explosive vision. Paleontologist Gregory Redelak thinks the reality was much quieter. According to him, back then, creatures weren't killed by massive blasts or suffocation, but rather by a more sinister force: altitude sickness. When methane flooded our atmosphere, air pressure plummeted, making it feel like we were constantly living at an altitude of about 4 kilometers high. It wasn't the lack of oxygen that did in most species. It was the damage caused to their lungs and brains from swollen tissues, struggling to cope with the thin air. In Redelak's view, the real survivors of this brutal extinction were those with a unique advantage: thicker ribs and barrel-shaped chests. These adapted bodies allowed them to breathe more efficiently, giving them just enough edge to make it through one of Earth's most devastating events. Now, let's bring this back home. For us humans, surviving such a dramatic drop in oxygen would be nearly impossible. The good news is we don't have to rely on our hypothetical survival skills just yet, or do we? Methane, the potent gas behind Redelak's altitude sickness theory, has both natural and human-made sources, from tropical swamps to industrial emissions. It's a naturally occurring element that, under normal circumstances, follows a delicate balance of absorption and release. But in 2006, researchers Yu and Nisbet made an alarming discovery: the methane concentration just started climbing for no apparent reason. and we're still wondering what this might mean for our future. Could we be heading towards a real-life methane apocalypse? Fast forward to 2020, and we're looking at a methane emissions crisis that's not just rising. It's accelerating at alarming rates, shattering records that leave us shaken. But here's the kicker: scientists are stumped. They can't pinpoint what's driving this surge. One theory suggests our swampy friends might be growing in size, but let's be real, how could swamps expand that quickly? I think it's time to dive a little deeper. Literally. Check out this map revealing vast deposits of methane hydrates hidden beneath the ocean's surface. What if an underwater earthquake or an unusually warm current gave these sleeping giants a nudge? The possibility is chilling. What if we've just disturbed a massive, ancient reserve of methane, unleashing it into our atmosphere with unforeseeable consequences? Imagine this scenario: a sudden chain reaction, unleashing methane in a catastrophic wave that could wipe out life as we know it. Coastal residents, nearly 2.5 billion people, would be the first to face the devastating consequences, their lives lost instantly. The explosive mix would then spread deep into continents, sparking massive forest fires with outcomes we can only dread. And as if that weren't enough, the thinning air would cause agonizing deaths from lung or brain swelling. But there's a glimmer of hope: those living above 2,500 meters might just stand a chance, escaping the worst of this apocalyptic scenario. You might be thinking that's only a tiny fraction of survivors. Less than 1% of our global population would make it through this disaster. But here's a surprising fact: even in the worst-case scenario, humanity wouldn't become extinct overnight. Remember the Mount Toba eruption? Just 27.5 million people survived, which is roughly 9,000 times fewer than the number that could survive this methane catastrophe. So, we do have a slim chance of making it through. Still, there's always the possibility we might be overlooking something crucial. And even if we do manage to cling on, life for those who remain would become an unimaginable struggle. Imagine facing unrelenting challenges in a drastically changed world. Life after